first. Now we can start. Welcome to World Futures Day on Voices 2025. This session is brought to you by Teach the Future, a global nonprofit dedicated to embedding futures literacy in education worldwide. World Futures Day is an initiative in partnership with the Millennium Project. They have been doing this for more than 11 years. This is our 5th year working with the youth, but they have been doing this for more than 11 years, the Millennium Project. We are part of a 24-hour conversation. Our colleague Amna and our colleague Lisa has been awake and are going to be awake for the whole 24 hours. So I hope they can sleep tomorrow for 24 hours, because if not, it's going to be really hard for them. But the most important thing is that we can bring intergenerational conversations, because the world is inhabited by intergenerational people, not only adults, but also youth. And it's important, really important for us that youth can have a voice. So with that, I will leave the floor to you. All yours. Thank you.
Thank you. Hello from us. My name is Mariana Filipova, and I'm here today with my students. We are from Bulgaria, STEALM Academy Quantum School, and this is the first school in the world that has subject like quantum science and technologies in its curriculum, and they have such a subject. We have chosen to participate in the World Future Day because we strongly believe that people should be prepared for the future, having the needed preparation in the scientific, business, and every aspect of life in every field. I mean, having the contemporary education and preparing for the global market that they're going to actually participate in 3, 4 to 5 years because of their different age. But actually, these are the new minds, the young voices of the future that have to be prepared for the things that expect them very near. And I have prepared some questions for them. I'll start with the first one, and it is, of course, the beginning of the topic. What are the quantum technologies and how revolutionary are they? What is their difference from the conventional technologies that we use today? So, Nedi, would you be pleased to start?
Hello, my name is Neda Borisov. I'm going to answer this question. So my answer is that the conventional computers we use every day process information using bits that can be in one of two states, 0 or 1. These computers operate on classical logic and are extremely powerful for tasks such as processing large amounts of data or solving complex calculations that can be modeled classically. Quantum computers, on the other hand, use quantum bits, which are called qubits, which can be in many more states thanks to the principles of quantum mechanics, such as superposition and entanglement. This allows quantum computers to perform parallel calculations, which give them a huge advantage in solving certain tasks that would take too long for classical computers, such as cryptography or modeling molecules. Quantum computers are still in their early stages of developing, and their real world is still under investigation, while classical computers continue to dominate everyday tasks. Ellie, what do you think?
Ellie, what do you think?
I'd like to take the word now. Quantum technologies, particularly quantum computing, are revolutionary because they harness the principles of quantum technologies. While classical computing relies on binary bits, quantum computing uses quantum bits, also known as qubits, which can exist in multiple states simultaneously due to superposition. This allows quantum computers to process huge amounts of data and perform complex calculations much faster than classical computers. Additionally, quantum entanglement allows qubits to be correlated in ways that classical bits cannot. This creates the possibility for more powerful and efficient information processing. From the invention of the first mechanical computers to the development of transistors in the 1940s, computers evolved to become faster, smaller, and more reliable. It is predicted that in the future they will be used in virtually every scientific field. That's all from me. Thank you. I'd like to pass the word on to my colleague.
Thank you very much, Ellie. But when we speak about future, we cannot mention the desired and the predictable future. So I will also continue with a question aimed to you about the vision of the future in the context of the quantum technologies. What realistic scenarios can we foresee, according to you?
Although we cannot predict the future, quantum technologies can change how we view it due to their promising potential to advance virtually every scientific field. We can envision advancements in cybersecurity, finance, biology and medicine, and many more. Furthermore, we are already seeing promising and desirable futures unfolding. For example, researchers at the Nanoscale Magnetic Resonance Imaging Lab at University of Waterloo have used quantum technologies to enhance the capabilities of MRI to the nanometer scale. Another example is Protein Cure, which has partnered with companies like IBM, AstraZeneca, and others to model proteins using quantum computing's potential. Those engineered proteins are then used for targeted medical purpose.
Thank you very much for your answer. Now I'm continuing with the questions, and Darina is the person who is going to continue. The question is, what are the unsolved problems that we expect quantum technologies to solve? There are a lot of classical computer problems that cannot be resolved with nowadays technologies that exist, and we rely on quantum technologies for such decisions and to overcome these problems. Dari, what do you think about that?
Well, quantum computers have the potential to solve in ways that traditional computers never could. Unlike conventional computers, which process information using bytes, 0 second and 1 second, quantum computers use qubits, allowing them to perform complex calculations way faster. Imagine the difference between an old Nokia phone and the newest iPhone 16. Quantum computers are the next generation of computational power. With this capability, we'll be able to solve challenges that seem impossible today, such as climate changes, global warming, analyzing large data sets, and predicting environmental changes with high accuracy. Space exploring and astronomy, simulating the universe, finding new planets, and understanding black holes. Drug discovery and medicine, developing new treatments faster by simulating molecular interactions. These are just a few examples of how quantum computers will help us solve many global changes faster than we can ever imagine.
Thank you very much, Dari. And when we speak about the fundamental concepts in the quantum computing, we cannot miss the superposition and quantum entanglement. Here, I will invite Christian to tell us much more about the applications and phenomena outside the lab, having in mind these very, very important fundamental concepts.
Hello. First, I will talk about the quantum superposition. And as I like to say, the secret weapon of quantum computers. As you know, in classical physics, everything has a well-defined state. It's either one thing or the other. But in quantum mechanics, particles can be in more than one state at the same time. This phenomenon is called quantum superposition. What does this mean for the computer technology? While regular computers use bits, 0 or 1, quantum computers use qubits, which can be in both 0 and 1 at the same time. This means that quantum computers can perform a huge number of calculations in parallel, rather than one after another. Imagine solving a complex math problem. A regular computer does it step by step, while a quantum computer looks at all possible answers at once. So now about the quantum entanglement, communication without boundaries. This is how I like to tell about the quantum entanglement. So one of the most incredible phenomenon in quantum mechanics is the quantum entanglement. This means that two particles can be so connected that a change in one will instantly affect the other, no matter how far apart they are. Why is this important? This principle can be used for quantum communication, which is completely secure and impossible to eavesdrop on image. And image having two entangled particles, one is with you and the other is on the other side of the earth, or on the other side of the world. If someone tries to read the information, it will be immediately detected and impossible for the other one who tries to read the text to read it. And in fact, the first particle application of quantum entanglement are already a reality. The Chinese satellite Meteos successfully carried out the first fully secure quantum communication between Earth and space. This shows that in the future, we may have completely secure communication system that no one can hack. Thank you, and I will pass the word for the next to my colleague.
Thank you very much, Christian. You have started a very important topic connected to quantum technologies, and it is the completely protected communication. I would like we to continue this topic and to speak about a little bit more about the challenges that are in front of these technologies to develop easily and to see them in the everyday life immediately. And I would like to invite Dari to start speaking about these challenges.
Thank you. I would like to say that with greater power comes greater responsibility. Quantum computers would not only speed up problem solving, but also transform cybersecurity. Today, many security systems rely on encryption methods that could be broken by powerful quantum computers. However, quantum cryptography will protect confidential data in ways never seen before. Key advancements in cybersecurity with quantum technology include unbreakable incorporation. Quantum key distribution ensures that messages cannot be intercept without detection. Secure communication. No one will be able to hack or read private conversations due to quantum entanglement. Protection of personal data. Quantum cryptography will help eliminate privacy concerns in the digital world. In short, quantum computers will bring a new level of security, making cyber attacks almost impossible. And now I would like to hear my colleague Christian's thoughts.
So, hello from me again. The quantum cyber security and the most secure protection for the future. So, we all use the internet, online banking, social media, email, but are we completely sure that our personal data is protected? Traditional cryptography, which we rely on today, is based on mathematical algorithms that even the most powerful computers find hard to break. The problem is that with the development of quantum computers, these algorithms will become outdated. Quantum calculators will be able to decode them in seconds. The solution. What is the solution? So quantum cryptography is the solution. It uses the principles of quantum entanglement and quantum superposition to guarantee absolutely secure for communication. Thanks to quantum distribution, QKD, we can immediately know if someone is trying to eavesdrop on our message or our messages, because the very act of measuring the quantum system changes its state. This means that no one can copy our data without being detected. I've shared my point. Now, Nedelina, it's your time to share your point.
Hello from me. Now I'll tell you my answer to the question. So quantum technologies have great potential to transform the financial sector. Quantum computers can analyze large volumes of data and solve complex problems much faster than traditional computers. This could improve the processes of optimizing investment portfolios, forecasting market trends, and managing risks. However, quantum technologies are still in their early stages of development and face challenges such as stability and limitations. Despite these difficulties, they promise significant innovations and improvements in the efficiency of financial service in the future. And now let's hear from Anton on this topic.
Tony, hi, and probably not exactly on this topic, but going in deep in this topic, I would like to connect it to the quantum clocks, to the atomic clocks that provide unparalleled precision. Please tell me, what do you think about their impact and the satellite technology and navigation connection to the quantum nowadays, and of course of the future?
Thank you very much for giving me the word. Hello from me. I would like to begin with something very closely tied with quantum technology. When we talk about the fundamental elements of quantum technology, two key chemical elements play a crucial role: rubidium and cesium. These elements are essential components of quantum atomic clocks, which are one of the most advanced timekeeping technologies ever developed. But why do we need atomic clocks? Our simple old clock on our hand, does it work? Their primary function is to ensure precision in satellite navigation and global positioning systems, also known as GPS. According to NASA's Jet Propulsion Laboratory, JPL, current satellite technology faces a limitation. Time delays create uncertainty in location tracking. For instance, it currently takes 40 minutes to pinpoint the exact location of a space object due to timing inaccuracies. Imagine what can happen of a satellite which costs billions, if I can say, in 40 minutes. Airport radars depend on real-time satellite image. A flaw in synchronization can lead to serious consequences. One of the most tragic examples is the disappearance of the Malaysian flight MH370, which demonstrates the risk of unreliable tracking systems. In 2014, this plane disappeared as it never existed. Quantum atomic clocks aim to solve this issue by improving photon exchange between Earth and satellites. By increasing accuracy, we would see a major advancements in GPS precision, eliminating time errors and enhancing navigation. Also, aerospace tracking will be influenced a lot by the quantum atomic clocks. This would allow us a real-time monitoring of spacecrafts and celestial bodies. And quantum space communications, as already mentioned from my colleagues, would enable us more secure and efficient data transmission between satellites and ground stations. As we know, China, with its all quantum experiments, is now also in the lead. They have already made significant progress in quantum satellite technology. One key experiment demonstrated the two-photon exchange distribution over 1,200 kilometers, proving the potential quantum communications for global networking. I would like to pass the word to my colleague Jana.
Jana, you're welcome, and I would like to connect the satellites with the other industries that are very important, like finances and medicines, and their future transformation due to quantum technologies. To prepare for that, we should have an education that is contemporary and also a good politics to prepare for future professionals. How do you think we can reach this aim that we have in front of us?
Technological development implies preparation with current knowledge. With knowledge for the past, it will be like historical facts to us. But we need to learn about the future labor market in which we will be participants. Our generation will have set new standards for the successful students for the necessary knowledge and natural science and technologies. Many professions will disappear and others will emerge. The profession that exists today and will exist in the future will develop. They will have different requirements that today's students must meet with knowledge and skills. Our generation is a generation of the future, and it is up to us to prepare for the future life. I'd love to hear Dorina share their thought next.
Thank you very much. I will be continuing. If quantum technology is going to shape our future, why aren't we teaching it to children today? Imagine something so important, yet it's not included in education. This needs to change. Preparing students for the future careers, many jobs in the future will require quantum knowledge. So, students must learn about it early. Incorporating quantum science into school curricula, just like we study physics, chemistry, and mathematics, quantum mechanics should be a part of science classes. Making quantum concepts accessible, even young students can understand basic quantum ideas through simple experiments and games. Including quantum topics in education ensures that the next generation is ready to work in cutting edge technology and use it for solving real world problems. Thank you.
Thank you very much, Darim. I would like to continue with a question that is about the connection between quantum technologies, advancement in technologies as a whole, and the society's value. Always when we have such a big development in the computing area and in technological one, we have a different kind of thinking in the ethics, security aspects, and we speak again for personal freedom and the things that can be affected from everything that happens every day and around us with this big speed. So here I think that Jana can tell us more about this influence that we expect to happen.
Okay, thank you. It is essential to introduce quantum scientific and technological concepts from early age, fostering curiosity and a solid foundation in this rapidly evolving field. Developing persistence and resilience in learning alongside exposure to global perspectives such as Europe quantum culture and Australia quantum mindset will help shape a new generation of quantum literacy and individuals. Regardless of the terminology used wherever, building knowledge, skills, or confidence in quantum sciences. The key objective remains the same: equipping today's learners with the expertise needed to drive the future of quantum technology and innovation. And now let's hear from Christian on this topic.
The influence of quantum technologies on psychology is an interesting and developing field of study. True quantum technologies directly apply to areas such as computing, cryptography, and communication. And their profound indirect influences on psychology. Now I'll list you some of the major domains where psychology and quantum technologies interact. First, cognitive shifts and human perception. Quantum mechanics impose rules which are contradictory to the classical thought, and that are superposition, which I already talked, and entanglement, that I already talked too, and uncertainty principle. These concepts have the potential to influence cognitive flexibility, which can enhance problem-solving capacity, abstract thinking, and creativity, and they can also create cognitive dissonance because they contravene daily logic. This causing confusion or resistance in the subjects. And the second one is the quantum models in psychology and neuroscience. Quantum theories are being investigated in neuros, neur, sorry, neuroscience and psychology to describe higher mental processes. Some of the areas include quantum cognition, propose that human decisions making and thought process adhere to probabilistic laws akin to the of quantum mechanics as opposed to classical logic. Quantum consciousness. Roger Penrose and Stuart Hameroff ideas propose that uh, consciousness is the result of quantum process in the brain, and more specifically in the microtubules within neurons. Quantum probability in decision making. It has been proven through research that human decisions making, if anything under uncertainty, is better explained by quantum probability theory than by classical probability. Third one is the psychological responses to quantum technologies. With the development of quantum technologies, they could activate psychological reaction including techno-optimism. Others view quantum technology as a revolution power that can bring advancement in artificial intelligence, medicine, and solution in energy sector. Techno anxiety and fear of the unknown. Quantum mechanics unpredictability and complexity can cause anxiety, particularly with regards to cybersecurity threats. Encryption being broken by quantum computers. Trust issues and conspiracy theories. The counter, counterintuitive and abstract nature of quantum physics has spawned misconceptions, at times giving rise to pseudoscience and conspiracy theories, like quantum healing or telepathy assertions. The fourth one and the last, oh no, sorry, the fourth one, the effect on mental health and treatment. Quantum technologies can affect psychology and mental health care in the following ways. Quantum-based brain imaging and AI quantum computing has the potential to enhance neuroscience studies and therefore more precise diagnostics and customized mental health intervention. Quantum-inspired psychotherapy models. Some therapies foray into quantum metaphors, like multiple possible selves in therapy, to help clients understand change and uncertainty in life. And the fifth and last, ethical and existential issue quantum. Technologies challenge basic presumption regarding reality, free will, and consciousness. This can lead to existential reflection. Quantum mechanics, determinism, or randomness can impact philosophical and psychological notion of indefined and free will. Ethical issues. Quantum technologies used in AI and surveillance can result in psychological ethical issues related to privacy, agency, and human rights. Conclusion that quantum technologies are revolutionizing cognition, decision-making, and consciousness, and are affected emotions, trust, and mental health. As they continue to develop, they will remain force shaping psychology, research, and daily life. So this is from me, and I'll pass the word to my colleagues.
Thank you very much, Christian, for the detailed presentation on this question. artificial intelligence, quantum technologies, and bioengineering all are the contemporary fields that are advancing simultaneously. But what are the benefits and also the risks of these fields evolving together? I would like to ask Elena to start with the response of this question.
Thank you very much. My answer is in 1912, the French chemist Stéphane Leduc first used the term synthetic biology, an emerging field of bioengineering. It is focused on redesigning organisms to have new abilities or serve new purposes and differs from genome editing as it requires more complex changes to the organism's DNA. Some applications of synthetic biology are antibody, vaccine, biofuel, and food productions. Quantum technologies have the potential to advance and accelerate the development of these fields. However, it would require us to answer some of the ethical questions that are related to them. For instance, if humanity is crossing moral boundaries, who in society will have access to developments, and what are the environmental impacts of introducing modified organisms into ecosystems? At the end of 2024, Wired magazine published an article titled "Designer Babies Are Teenagers Now, and Some of Them Need Therapy Because of It." And it is an excellent example of the impact of those ethical issues. Basically, many parents didn't realize they were creating a human being and not an emotionless object. That's all I have to say. I'll pass the word over to the next person.
Thank you very much. I will invite Anton to continue the response because I know that he has an additional point of view.
Yes, thank you very much. Hello from me again. So, I believe that the fusion of quantum technology and artificial intelligence will completely transform science and technology as we know it. One of the biggest impacts will be the end of classical computing as quantum computing takes over everything. Quantum computers will replace today's supercomputers. Current AI models are limited by classical processing power, but quantum computers will accelerate problem solving to unimaginable speeds. Also, quantum internet will redefine connectivity. This will happen by utilizing quantum entanglement. Information will be transmitted instantly across vast distances, making today's internet seem very, very outdated. Also, the impossible problems will be solved in seconds. What once took years of computing could be reduced to milliseconds by quantum technology. Appliances of the quantum fusion between AI and quantum computers are many. As said before from my colleague, quantum technology can help in bioengineering, but I I would like to have a little bit of a view of the past. Did you know that, for example, AI will help this fusion will help a lot archaeology? Probably you wonder why. Archaeology is just digging up some old artifacts, but it has cultural value, as we know, ethical value. Quantum AI will help archaeologists locate historical sites by analyzing data faster than ever before, because people before lived everywhere, as now we don't know all the places where they lived. So we need someone to help us in this journey of exploring our past and our culture. Also, it will help us preserving ancient texts. AI-assisted quantum computing is already helping researchers decode unreadable ancient scrolls such as the Herculaneum scrolls. Also, quantum enhanced AI models could double the number of known Nazca geoglyphs by analyzing satellite image more efficiently. This is connected a lot with geospatial sciences, which are also very important for the development of the future. By merging quantum technology and artificial intelligence, will mark the beginning of a new era of discovery and innovation where today's limitations will become a thing of the past. And that was all points from me.
Thank you very much, Tony. I would like to ask you about the quantum technologies impact on the transport with logistics and communication. Will we see radical changes in these industries? What is your opinion?
Thank you very much. I believe there will be radical changes. Today, we speak about all these changes. Transportation, logistics are just one of the few. According to the annual research of the US Department of Transportation, quantum computers have the potential to solve some problems much faster than computers today in areas like optimizing, machine learning, and artificial intelligence, and material sciences. This quantum advantage has been explored in problems like uh, placement of electrical vehicle changing stations, which is important for our mobility. Also, the 5G cell towers. Where is the best place to place your cell tower? Because we need better communication. Also, emergency evacuation planning and flash flood predictions. Scientists identified 18 priority areas, including optimizing networks for safety, also for being more efficient, and the accessibility for all people, no matter who they are. Another aspect of the development of quantum technologies and transportation simultaneously was proven by the London Underground. I don't know if you know, the London Underground hosts trials of GPS alternative quantum compass. Tests are being held in the nowadays in the London Underground for a quantum compass that could replace GPS as a whole and allow to navigate without relying on external signals. I believe logistics in delivery are especially important nowadays with all those deliveries we make online. One of the biggest corporations working with quantum technologies, IBM, has made uh, several experiments with different delivery companies. For example, they claim that by using quantum computers, by feeding them, if I can say, a global routing optimization, they could help us significantly reduce door-to-door transportation costs and boost customer satisfaction. IBM worked with a commercial vehicle manufacturer um, to show us how a quantum computer will operate in this kind of situation. The experiment happened in New York City, and it was between 1,200 locations. By using this quantum computer, they had 30 minutes more by optimization, which also saved them a lot of money, which is very good for the logistics. Also, IBM claims that quantum computers could support better decision making by simulating more disruption scenarios and quantifying their impact on various parts of the road network. For example, quantum computers uh, will help us predict different scenarios, for example, problems which could occur on the road of transportation and logistics. Um, in addition to that, quantum machine learning may enable more precise classification and prediction of disruption events. So with that, I believe that quantum technologies uh, will change radically the transportation, logistics, and communications, as I already said, from the experiment from China, for example. Thank you.
Thank you very much, Tony. Thank you. Now I would like to pay attention to the quantum communication again. Quantum communication is a key to developing science, business, and life as a whole. I would like we to describe a little bit more. Yeah, there is a question. Sorry, I have already seen. Miss Rodriguez, would you like to ask something?
No, just for me to know how many more students we talk, because we will have 5 minutes for questions at the end.
Yeah, we are at the final part. So yeah, thank you very much. So Dari, would you be pleased to continue?
Yes, thank you. And I would like to say that one of the biggest advantages of quantum technology is the polarized quantum communication, a system where no one can hack or read private messages. Quantum entanglement ensures security. If someone tries to intercept a quantum message, the system will immediately detect it. Building a future without cybercrime. The more developing quantum communication, the more difficult it becomes for hackers to break into the system. Governments and businesses will rely on quantum networks. Sensitive information will be transmitted using quantum secure systems, ensuring that the financial and military data remains confidential. In the near future, our world will rely on quantum secured communication, making the digital interactions safer than ever before. Thank you.
Thank you, Dari. And final words for a conclusion. What advice would you give to your peers in preparing for the future?
By learning step by step, students can build solid foundation. They will be able to use quantum ideas in different areas of science and technology. No matter that we call or what we call all this process, the most important thing is to start now. The future of quantum science depends on how well today's students learn and grow in this exciting field. So start preparation from today. Thank you.
Mariana, you're mute.
Thank you very much. So that's the final part, and we're ready for questions if there are any.
Wow, thank you so much to all of you for your amazing work, your amazing reflections, for sharing this knowledge. I didn't know any of this, so I have learned a lot from you. As you can see, adults can learn from the youth and the other way around. So thank you so much for this. I would like to ask you as students, after all this research, all this knowledge, what is like the thing that impressed you the most, impacted you the most when you were learning these things, like surprised you the most? What are the things that you say, oh, wow, I didn't expect that with quantum? Any of you can open the mic. There is no right or wrong questions. Yes, Darina.
Yeah, I would like to say that for me, solving so big problems that now everyone thinks that are impossible, that our future will get worse if we don't solve them. I don't believe that something can solve them so fast and so easy.
This is a great reflection, Darina. Thank you so much. Anton.
I would like me, honestly, the most surprising part of all these quantum innovations was honestly the change of satellite technologies. Honestly, I believed for now that before I believed this was the best the communications we would ever have, and we wouldn't have any improvements. But later I found about quantum technologies, and I had I had a look about what our future would look like with better communication. I honestly believe that quantum technologies aren't just theories, as you know, physics and so on. They are actively reshaping science and space exploration and cybersecurity, as today all of us mentioned. Uh, by showing these advancements, we are stepping into a future where the impossible becomes reality.
Thank you so much, Anton. This was also super insightful. Thank you. Anyone else? I have a comment in the chat that says, from Scott Jordan, thank you all. This was incredible. How do you get people to learn such complicated concepts? And he has a question for you. Do you think that we, as the global community in the World Future Day, how we can prepare for a quantum future? What you will say is the first step? What should we do next? Yes, Darina.
For me, one of the most important thing is to have interest in what you're learning and not just memorize it because it's important. Because if you love something, if you enjoy it, you will learn more and more, and that way you become a better version of yourself. Thank you.
Thank you, Darina. And this is for you, Mariana. Congratulations, because you made them feel the curiosity for this topic and feel like the passion for it. So it's not just memorizing, but learning. Thank you, Mariana.
Thank you very much for the opportunity to participate in the World Futures Day, and we hope to be always part of this initiative in the future. So a big thank you to all of you.
Thank you so much. Thank you all. I left in the chat some links. Specifically important is the certificate of participation. It's a really quick survey. You answer what you enjoy the most of this session, but also other sessions, and you will receive a certificate. And we have also some online courses of future thinking that we are launching, and you can pre-register here. With that, I think we can go to the main room, and we still have many sessions coming. So I hope you can join and continue learning from this global community. Thank you again. Thank you so much. It was wonderful. Thank you. Big applause.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you. Do you know how to go to the main room? You click in the breakout group and then you select go to the main room. Or, yeah, exactly.